Hi, this is James from Mission, and today on the Effectsblog we're going to be making bombs. If you're building electronics products such as effects pedals, you're going to be making a lot of bombs. No, not that type of bomb, but bomb as in BOM, or bill of materials. A bill of materials is basically a list of all the components that you're going to need in your project. You can use a bomb to send to component suppliers as a kind of shopping list. You'll also need it to send to your contract manufacturers whenever you're going to have products assembled for you. A BOM is useful for managing components so you can find the best prices and alternative parts if something is no longer available. You can also use a BOM to help determine the selling price of your product. Okay, let's go over to the desktop and make a BOM. Alright, so here we are at the desktop. Let's get started with building our first BOM. The first one we're going to do is a PCB level BOM. So this is all the components that are on our PCB derived from our schematic. There's also a system level BOM which includes, for an effects pedal, things like the chassis and knobs and switches, maybe also the box and that it ships in and the instruction manual, those kinds of things. But we'll add those later. We're going to start with the components on the PCB. You could do this manually just by writing them into a spreadsheet, but if you're using a PCB design tool, quite often those have the ability to export the components as a BOM. So that's what we're going to get started with here. And I'm using Eagle here, and I've just opened one of the example projects that comes as default with Eagle, just so that we can see how it creates a BOM. Right, we'll select that. We need to be in the schematic view for this to work. And then you open File. I'm using Mac here, so it may be slightly different on Windows, but most of the procedures are the same. And then we're going to run a ULP. So just click on there, and then we're going to select where that is. I've just created a Effectsblog BOM folder on my desktop, and bom.ulp comes as default with Eagle. So we're going to open that. And you can see it creates the bill of materials right here. Bring that over to the middle. So there we go, and there are all our parts as they're labeled on the PCB, and there's the value if those have been included. So I would normally recommend when you're creating your schematic that you make sure you include the values when you're doing this. Then there's also some information in there about the package of the device, and then it may have a description in there as well, and we can add and modify this in the spreadsheet afterwards as we need to. I normally choose text as the output. You can select the output here, text, CSV or HTML. I normally choose text because I don't necessarily know what I'm going to be looking at the data in afterwards or how I'm going to convert it. And if I save it as a CSV, Eagle I think uses semicolons as a separator, and that doesn't work as default with Excel, which I use. So you end up having to manipulate it a little bit. So if I just save it as text, then I can import the text into whatever tool I'm using at the time, which may be Excel or maybe something else, and it may be on Mac or it may be on Windows. So text is normally the best way to save it, and then you can import it. And I'm going to show you how to do that. So let's just go ahead and do it. I'm going to save it, and we'll save it to our folder that we have created, and then we'll call it, say, testbomb.txt, and then we'll save it. And then I already created one earlier, so we'll overwrite it. There we go. So that's done. We've outputted the BOM. So now we need to import it into something. So I'm using Excel. So I'll open Excel, and we'll do File, and then Import. And then it's a text file that I'm going to import. So I select that. Now it's going to ask for the file that I want to import, which is this one. We'll do Get Data. And now this is the separator part. This is where I can tell it how I want to delimit the file as it turns out in the finished article. So that all looks good. That all looks good. That all looks good. So we'll call it finish. And we'll create, we'll put it in the existing sheet. I don't need to create a new one. So we'll select that. And there we go. It's created the spreadsheet for us. So this is our default BOM that we're going to get. So I'm just going to edit a couple of these things that it's deposited in the spreadsheet. The first one is this tells us where it comes from, and we don't need that. So we're going to delete that section right there, and then we're just going to write in our title, test BOM, and we'll give it a date. And normally you want to have a version number so that when you update this, we have some sort of primitive versioning control if you make a change to it. So we'll call it version 0.1, and we'll add in the date as well, which is I have no idea what the date is, so we'll put in 4/1/14 just in case that's it. Then we'll save that, and then we'll bold this out, which is our title line, so that we can see what's going on in there. And this is a good starting point. You can see that we have now in column A we have our part number, and these are the part numbers as they're identified on the PCB, and this is going to be very useful for your assembly house, for your contract manufacturer, and also for a component vendor. If you're going to send them the BOM, this will identify each of the individual components. Here's the value for those components where we have them, the device type, and the packaging type. And this again is going to be very useful for us when we're looking at purchasing the parts, and we can update extra information in there too. And then this says what type of component it is. For some reason it's missed a couple of those, so we're just going to add those in there, and then we should be pretty much good to go. Now we want to add some additional information that will help us in the acquisition of the parts that's not included when you do the export. So we're going to add a few extra columns in here. The first one we're going to do manufacturing part number, and then we're going to do vendor part number in there, and then we're going to add a link in there, and I'll tell you what these all are in a minute. And then we're going to do price per 100, and then we may have a alternate, and then we're going to add notes, and these are commonly the ones that I start with when I'm building a BOM. So manufacturing part number here, this is the manufacturer's part number. So we're going to look into this. We're going to see if we can go acquire this capacitor here in a minute, and the manufacturer's number will be the part number for that particular component from the manufacturer themselves. So if we choose a Panasonic capacitor, for instance, this will be a Panasonic part number in there. If it's a Vichy, then there'll be a Vichy part number in there. The number to identify the part from whoever manufactures it. And that's different to the vendor part number, which is the part number from where we buy it from. So if it's a Panasonic cat, it'll be Panasonic's number in here. If we go buy it from Allied Electronics, for example, it will be the Allied Electronics number in here for this particular part. And the reason that we have those both in there is that I need the part number from the vendor in order to order the part. So when I go place a PO, I'm going to need that number right here with the vendor to order the part. The manufacturing number I need to identify it specifically and to send to other vendors. So if I'm going to export my BOM and send it out to a bunch of different vendors, a lot of them will allow you to send them a BOM in a spreadsheet, and then they will come back with a price or a quote, or allow you to order per BOM. So you just fill out the spreadsheet and you send that there. If you're going to send that to a bunch of different vendors, then you don't want to have the vendor number in here. You'll just have the manufacturing number.
So that's the reason we have both those in there. A link is one that I include. This is normally just a web link to the component where I intend to buy it from. So if I'm going to buy this from Allied, I'll put a link in there to their page, and that will take me right there so I can go check all the data, and it's a good place to go back to download the data sheets and that kind of stuff. Price per 100. Now this depends on what type of project you're building and the sort of quantities that you build it in. When I'm pricing out a project, I will normally base it on the price per 100 units when I'm first doing a BOM. This will tell me for a rough idea about how much my project is going to cost me per 100 units, because I'm normally going to build at least 100 in one go. If you're going to be building less than that, then you'll need to adjust this appropriately, and if you're going to be building more than that, then you can adjust it appropriately depending on how you buy those components. If you buy them one at a time, put price 1. If you buy them 100 per 100, if you buy them 10,000 at a time, then write that number in there, and that'll help you price out your project at the end. Alternate is usually an alternate part or an alternate vendor. Sometimes I might not be able to get the specific manufacturer's part number that I need, and I want to have an alternate in the event that that's no longer available or is out of stock at this point. So I'll normally put an alternate part in here, and then in any notes here on the particular part that I need to remind myself of will go in right there. Okay, so I've made the fonts a little bigger here so we can see what we're doing. And let's see if we can go get some parts for our BOM. So let's start with the first part, C1. And I notice here that C1 and C2 are the same part. And then actually C3 and C4 are the same part, and C5 and C6 are the same part. If I had a lot of those parts that are all the same, maybe C1 and I have 20 of them on the same board, I will probably not have separate lines for them, and I'd just do something like this, C1, C2, and put those part numbers in there, and then I'd add a column over here that said quantity, and that way that would stop us having too many rows of the same part, and make the spreadsheet a little more manageable. But since in this case we're doing an example and we only have a few parts, it's easy to keep it like this, so let's do that. Okay, so let's see if we can populate C1 and C2. So we have a 10 microfarad capacitor. I can see from the package that it's an electrolytic capacitor. And I want to check to see that I can get my mechanicals correct. Now if I had the board in hand, typically I would have the board out on my bench and I'd have some calipers and I'd measure around on the board to make sure I could fit everything in. But we'll since we don't have that here, we'll have to do it from our board layout diagram. So here's C1 and C2, and I have a 1mm pitch for these squares. So I've already measured this, and I happen to know that a 5mm or 4 or 5mm diameter cap will fit in here okay. And then I also have a pitch here, a lead spacing of about 2.5mm. It's 2.5mm lead spacing on these. So if I really wanted to match these parts up correctly, I would get an exact 2.5mm lead separation. Sometimes we may find that they're smaller than that, and in this case, through hole electrolytic caps, I can spread the leads out a little bit, so I have a little tolerance there. With something like a ceramic cap or an IC or a jumper, I don't have that, so I have to be absolutely precise with this pin spacing. I also need to know the diameter of the holes so that I can make sure that I'm not getting a lead that is too big to pass through the holes. Okay, so those are things that we'll need to know before we go get the parts, and we can get that from the board itself or the drawing or other technical documents that you have describing that. Okay, let's go get a part, see if we can find something that will match. So put in your where it is you want to go to get prices for parts. I use Allied Electronics quite a lot for prototyping. Lots of the electronics components vendors have websites with just the tools that we're going to go through now, so you can choose whichever is your favorite. I've just got used to using Allied for prototyping. So we will go to passive components and capacitors. And then down here is on the left hand side. Let's make this a little bigger. Here's where we select our filters, and this is where we can narrow down the type of caps that we're looking for, so we don't have 9,000 odd to choose from. So we know we want aluminum electrolytic. We know that it was a 10 microfarad part that we're looking for, so let's bring that up here. And sometimes you'll find they have the same part labeled slightly differently. So here I have 10 microfarad, and then I also have 10.0 microfarad, which is the same. So we'll tick those. Tolerance I'm not too worried about for this application. A standard 20% tolerance will be fine. Let's say maybe for voltage I might care. So let's say a 25 volt DC cap will meet our requirements here. Okay, and let's start with that. Let's filter on those and see what we have. Okay, there we go. So this gives us 39 parts to choose from. Okay, now I notice the first ones that come up are axial parts, and I don't want to really. My board layout is designed for radial parts, so I'm going to select radial, and then also I can see a lot of these appear to be SMT parts, which again we're not using here, so we can discount those. So I'm going to filter out axial and SMT, and that gets us down to 16 parts to choose from, which looks pretty good. The next thing I can filter by is case size. Now this tells me what the diameter of the part is and what the height of the part is. Now we already said we could fit a 5mm diameter part in there, so we're pretty good with that. I notice here that some of the parts are taller parts, so they are 11mm. Now if that meets our requirements, that's fine, we can go search through those. But let's say, just for the sake of argument, that 11mm is too tall and won't fit in. We have some mechanical interference, maybe it will bump into a switch or something. We need to be checking these things when we're speccing our parts. So let's say 11mm is too tall, so we'll choose the 5 and 7 and we'll add those filters and see what we get. Okay, that gets us down to 7 parts now, which is quite manageable. I can choose from these 7 parts. The next thing I'll do is I'll look at the manufacturers of the parts. I want a decent quality part for this product, so I'm going to choose from a manufacturer that I would trust. And I see that all these here are either, they're mostly Panasonic, and there's a Nikon in there as well. All of those are good quality vendors, so I'm happy with all of those. Don't need to filter those out. So next thing, let's take a look at price. This one's obviously out because it's not available, so that gets us down to 6 parts. The cheapest parts appear to be these ones here, but if we look at the stock quantities, we can see they're ordered in multiples of 2,000. So and they're going to come in a sort of package where you can only order a minimum of 2,000. And so if we look over at the description there, we can see it says tape and box. So these are already on a tape in a box, and these would be the parts that we would use if we were going to send them off to a contract manufacturer and have them put them in a pick and place machine. In this case, I'm just, in our little exercise here, we're just doing prototyping, and we're going to assemble them ourselves by hand. So we're not going to order them in the tape and the box. If I was planning on sending off a few hundred boards to a contract manufacturer to have them assemble them in pick and place, then I might go and purchase the 2,000 or 4,000 parts here because I get a pretty good price. But for now, we're going to stick with bulk that we can order in smaller quantities. So those are out, but I notice I have the next one is probably probably this one here, which is 0.06. So that's about 6 cents each. And this is probably the same part. It's probably the same one that's just ordered in a different quantity. So let's bring that up and we'll take a look at it. Here's the description of the part. So we can see it's aluminum electrolytic. It's 10 microfarad, tolerance of 20%, 25 volt DC, which is what we said we wanted. It's a radial part, so the leads are radial. That meets our requirements. It's bulk, so I can order them in any quantity. It's a 4mm by 7mm case size, so that meets our requirements too, so that looks good. Let's bring up the specs and look at it in a bit more detail. Everything looks good on there. The one thing I do notice is the lead spacing. So the lead spacing there is 1.5mm, and we've said we've got a 2.5mm lead spacing on our product. I could still make this work because 1.5mm I can just spread the legs out a little bit and just leave the cap a little higher on the board. That'll definitely work for prototyping. It's probably good enough for production as well for a hand soldered part. So I would say I am happy with that one. So we're going to include that in our BOM. Up here is the manufacturer part number and the vendor part number, which we know we need to populate in our spreadsheet. So let's copy them. Let's copy my manufacturer part number, and then we'll go over, let's minimize this, go over to our spreadsheet. So there's our manufacturer part number, so we'll just drop that in there. And then we need our vendor part number, which is this one here, so we'll copy that and we'll drop that in there. If I want to, I can put a link to that page in the website right here. I'll leave that out for just now, but you can put that in so that when you're looking at the BOM, you can always go back to where you got the specifications from. Price per 100. So let's look up price per 100. If I were to order these 100 at a time, it would be 0.47, so 0.47 of a cent each. So we'll put in 0.047. We'll save that. Now, since this is in price, I'm going to change the cells here. So I'm going to select that column. I'm going to format that as currency. There we go, and it rounds it up, so that's about 5 cents apart, which is fine for our purposes. Okay, this is an alternate. So let me just go back here, and we'll check. There's another one that they have here, which is this one here from NikeCon, different vendor. So let's take a look at that one. And 10 microfarad, 25 volts. Radial 4x7, 1.5mm lead spacing, so that it's pretty much exactly the same part there, but from the different vendor. And I like NikeCon parts too, so I'm going to do the same thing here. I'm going to select this as the alternate, and I'm going to drop that one in there. Okay, so that's my alternate part. Maybe I'll make a note in here. Alternate Nike. Okay, so that's done for that part, and then I can copy this down since the next one is exactly the same. I can copy this down, have a auto number on there. That's a very irritating feature of Excel spreadsheet that I need to learn to turn off. Okay, and that's that, and then that's also 5 cents. So we're good to go. We'll take this down here. There we go. Oops. Copy it up there. So we have both the same parts. There we can see again it changes the number. I really need to learn how to turn that off. Okay, so that's good. And then we'll just carry on. We would just carry on in the same way down here with all these different parts. So capacitors and diodes, our microcontroller. I normally try for prototyping to see if I can get the parts all from the same vendor, so I can just bundle them in and get one box full of all the parts I need to build a few prototypes. I'll normally build, you know, between 5 and 10 prototypes. Once I go to production, then I may change this with different vendors, because if I'm ordering thousands at a time, then it may make more sense to get different parts from a different vendor in order to get the price breaks. And this really depends on all sorts of factors in terms of shipping and price breaks and accounts terms and those kind of things. So I will normally give up at this point and pass these over to our operations department, who figures out all those pricing for more complex and larger quantities. But for prototyping and for doing your own thing, this is just fine. So we'll fill these in, or you can fill these in, or whatever. We won't do them right now, but basically it would be the same thing. Then what I'll do to get a kind of guide here is I'll make myself a little total row along here, and then that will contain the result of all the parts down here. Now of course they're all going to be different prices, but for the sake of this little test here, let's imagine they're all the same price, that they're all 5 cents. And then I'm going to do a little spreadsheet equation here. It'll equal sum, and then it's going to equal the sum of this one, 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 and this one. Okay, that's good. So there we go. So if those parts were all 5 cents each, we would see there that our total cost for those parts would be 56 cents. Now, of course, that's not going to be the case. Let's imagine that this is maybe $3. So we'll put in $3 for that. And there we see it goes up to $3.52 now along there. So as you figure out different pricing for those components, find different vendors you can get it at a lower cost. You can keep updating those, and this will come up with the total cost of the bill of materials for those components. Now, of course, I haven't got the board cost in here, so at this point maybe I might update this and I'll add some more rows in here. Insert. Okay, and maybe I'll put my board in here. So my board cost, maybe it cost me $3 to have the board made, and then maybe I have the assembly cost. I might put that in the BOM, which would be the assembly cost at the contract manufacturer. Maybe they charge me $4 to make the board, so I might put that in there. And then we'd update this down here, and you can keep adding those parts in order to build your complete BOM. I would normally keep the board level stuff separate right here, and then I would make a separate sheet, which would be my system level. So let's say this came over to 352. Well, then I'd go over here, and then I go PCB, and then we'd put in the price of the PCB and the vendor that I got it from, and so forth. And then I'd add in things like the enclosure, and then maybe we need some knobs. Maybe there's an LED that doesn't figure on the board, so I put those in. And all those things would all add up, and then I could do another totals field over here, and this would give me the total cost of building the product. I could add the box and the user guide and a label that I stick on the side of the box, and all the things that will go into making a production product. And then when you add that up, that will give you the total cost of the parts of building that particular product, and that will help you calculate what you need to sell the product for in order to make a living. All right, that's it. That is our little guide on how to create a BOM. Hope you enjoyed it. See you next time.